Hello, this is the sixth video for mathematics for computer science, and I'm going to talk about probability as much as I did in the last video, but this time I'm going to talk about the whole chapter instead of just explaining one chunk of it. So it's more like a concluded overview of that chapter. And before starting, I just want to give a recap on what we did conclude in the last video. So we know that probability is already defined as a mathematical concept and framework that can describe any pattern model that we have. So we already have all the necessary things for it. An example would be the event, probability, and variance and deviation. All these concepts and the theories that behold are already settled and invented. We just need to use them to, for example, in this case, analyze the randomness that exists and make the computer learn that analysis so we can foresee a pattern in there. Not exactly a predictable pattern, but just have a probability that we can, or a bounded probability that we can rely on. So first thing is I'm going to talk about how machines, they are designed to be deterministic for the most part. And when we introduce randomness, it is a strange concept for the machine, not only when generating random numbers, but also when handling randomness also too. So randomness will never be implemented natively in a machine, but rather it should be emulated through the whole mathematical framework that we have. And the question can be is how can we emulate randomness? And as I said, you just need to calculate explicitly the random steps or the pattern that the problem you're trying to resolve has. And uh, most of the people would say, why would you need to analyze randomness? And an answer for that would be the average will never be enough. And what I mean by average will never be enough, we can explain it in this concept uh, for this solution that Facebook had a problem with, where they had Facebook as a service, it has a lot of load. And they need to make sure that they balance that load that they have, since they have millions of requests each day and each minute. So assuming that each request, for example, it's going to take 10 seconds to process, an average of a 10 seconds to process, we should not take the assumption that that time is fixed to that average. It will be random and it will vary through that 10 seconds. The 10 seconds is only an average. And what I mean by average is not enough. And the answer that I said is assuming that in your strategy of load balancing that the process will always be 10 seconds would be fatal to your solution because only one random process that can happen with a different variance of that time, for example, 20 seconds or more, could really destroy the whole load balancing solution. And all your strategy can bite you in the rear. So here we need to calculate randomness, not only calculate it in an accurate way, but just calculate because it is impossible to calculate randomness precisely, otherwise it won't be randomness. But with the mathematical framework and advancement we have, we can have a bounded value through that randomness by calculating the expectation and the variance of that randomness, which will make us have a bounded interval of the probability of that process, where it will vary in between those 10 seconds and less or more. And the mathematical technical concept that we can use is, for example, what we studied in the book is Markov's inequality or Chernov's inequality theory. And moving on, there is more than that. I'm not going to explain them in details. You have to read the book to understand that part. But yeah, just as a reference to know what I'm trying to link here. Another reason we could need the randomness is, for example, what is the probability to see this video, or what is the probability that when you search through Google, you're gonna find what you need, uh, and the ranking solution that they use in the Google searches, they tend to search through all the links that exist, or the web pages that exist, and see the link between each web page and web pages. They're all linked with a link between them. I mean, for the most part. And if you see that as a graph, the node that has the most in degrees towards us is the one that is more important, which means it's the one that is more relevant in the search. But that can be tweaked, or let's say, used to play with it to make it to your advantage. For example, I could make dummy pages that are linked to my page, where it will give it more importance and more relevance. A solution that Google made is they made this web surfer, random web surfer, where they put it randomly in a page, and it will keep navigating through each page and page that are linked towards it. And through those web pages that is going, the more it's going to visit a one page, like in another time, the more relevant it is, and the more probability it is more important, which will give it more relevance in the search. And to calculate those probabilities, you need to know the concept of random walks, when you need to make sure that each random step, or like a successive random steps, can have a pattern, not a pattern exactly, but more like a probabilistic mathematical model, where you can have the relation that can modelize that pattern, and you can calculate a random n step, the probability of it. And from there, you're gonna have uh, your graph probabilistic model for each page, and you're going to use that to re-rank your solutions. That's another example just to explain how probability incline, or gets injected through computer science. And yeah, that's all, and I hope you understand the video. Thank you.